Now we want to consider the solution of the equation we're given here. Y prime minus y equals y to the negative 2. Fairly simple Bernoulli equation, but it illustrates the process. Now remember, we let v equal y to the m so that y equals v to the 1 over m. Y prime is then going to equal what it equals, and so forth. And if we just go back here, we don't really want to memorize these as formulas. We should be able to rederive them rather quickly. But if you got a good memory for formulas, you can do as you wish with that. What we see is that our equation becomes v prime plus m p of t plus 1 minus n p of t v equals 1 minus n times q of t. Applying that to the given equation, we're going to find that I guess we should also write down here that n is negative 2, so that our equation is going to become v prime plus m p of t v, m being 1 minus n, so that's going to be 1 minus n. Not really identifying everything here. We should also identify p of t as negative 1 and q of t as 1. Okay, so now we can substitute back here. So we got 1 minus n times p of t, which is in this case negative 1 times v, and that equals 1 minus n times q of t, which is 1. Now n is negative 2, so that v prime is, we have v prime plus 1 minus negative 2 is 1 plus 2. That's 3. We're going to have a negative, which means that I can get rid of my plus sign altogether. Okay, there we go. Now it looks better. So v prime minus 3 times v equals 3. This equation is now linear homogeneous. And easy to solve. We're going to use the integrating factor e to the integral of p of t. P of t in this form is negative 3. So we're going to multiply both sides by e to the negative 3t. And over here we're going to get 3e to the negative 3t. We see that the right-hand side is going to be easy to integrate. The left-hand side is just the derivative of e to the negative 3tv. So this is e to the negative 3tv prime equals 3e to the negative 3t, which leads us to integrate both sides. I'll just put the integral signs. That's a bad looking integral sign. Put the integral signs on both sides with respect to t and with respect to t. Have to kind of sneak that in. The integral of this side is just going to be e to the negative 3t times v. The integral of the right-hand side, and we'll include the integration constant when we integrate the right-hand side, is just going to be negative e to the negative 3t. Plus a constant. So that v is going to equal what? Well, if we divide both sides through by e to the negative 3t, we're going to get a negative 1 when we divide this, plus some arbitrary constant over e to the negative 3t. That's going to be negative 1 plus ce to the 3t. That's our v function. Now, of course, we're looking to solve for y. What's our y function? We can take this crib sheet away here and identify that y is v to the 1 over m, so that y equals v to the 1 over m equals the quantity c e to the 3t minus 1 raised to the 1 over m and since m is n minus 1, this is going to be 1 over, make sure I write this down correctly, 1 over 1 minus n, and n is the power of y, which is negative 2, so that's going to be the 1/3 power, so that y could be written as the cube root of c e to the 3t minus 1. We solve the equation y prime minus y equals e to the t y cubed, which we can identify as a Bernoulli equation. The form is y prime plus py equals qy to the n, where p is the coefficient of y, which is in this case negative 1, and q the coefficient of a power of y on the right hand side, that coefficient being e to the t and the power n being 3. So we can say p equals negative 1, q equals e to the t, n equals 3. I do recommend going through the entire process with these numbers. First I'm going to have to unblur the screen. Okay. Now, having identified our value of n and our p function and our q function, we can write out the transformed function, which is going to be v prime plus, okay, n is 3, so 1 minus n is negative 2, and left something out when I wrote this. It's times y here, so we're going to need that. It's negative 2 times y. Now p of t is negative 1, so actually that'll be, by the time we do the 1 minus n, which is negative 2, and the p of t, which is negative 1, we get 2y. And that equals negative 2 times our q of t function, our q of t function being e to the t. And this is v, not y. And this should also be v. And I can kind of make it into a v. There we go. Okay. Now, still kind of looks like a y. Okay, so we have the equation v prime plus 2v equals negative 2e to the t. We solve the equation as a linear non-homogeneous equation. Our left-hand side is our integrating factor is going to be e to the 2t. So we're going to have e to the 2t multiplied by v prime plus 2v equals negative 2e to the 2t times e to the t, giving us v e to the 2t prime on the left-hand side. Now you might have to review the thinking on a linear non-homogeneous equation, but hopefully you're used to that from having done that work in the recent past. Okay, so we have this. Over here we have negative 2e to the 3t. Integrating both sides, we get v e to the 2t, integrating with respect to t. v e to the 2t equals antiderivative of this, which is going to be negative 2/3 e to the 3t plus an integration constant. Solving for v, we get v, well, we're going to divide both sides by e to the 2t. We're going to get v equals negative 2/3 e to the t, because when we divide e to the 3t by e to the 2t, of course, we get e to the t, plus c divided by e to the 2t, which would be c e to the negative 2t. So here's our general v function. Now we haven't imposed any initial conditions on this equation or in the last one we solved, but now we can write out final steps, at least of our general solution. Okay, now just to make sure we see this, v of t equals negative 2/3 e to the t plus c e to the negative 2t, and our substitution was, well, the original substitution was v equals y to the m. We've encompassed the step where we see that m has to be negative 3 in order to reduce this to the form of a linear homogeneous equation. But we probably should have identified that step up here where m was equal to 1 minus n. In any case, v equals y to the m equals, in this case, y to the 1 minus n. So y equals v to the 1 over 1 minus n. And n equals 3, so that's v to the negative 1/2. And that is then negative 1/2 power, of course, is the square root. That's going to be 1 over the square root of 2/3. Let's write it in this order, c e to the negative 2t minus 2/3 e to the t. Now that form could be modified, simplified, etc. But this should illustrate the process.